Hello. We will start discussing Module 12, Foundation Solutions. So in this module, we will determine what are the different type of foundations, what are their uses, okay, ano yung mga uses nila in terms of their, saan sila magandang ginagamit, yung mga different foundation solutions. Also, we will determine what is the difference between the shallow and the deep foundations. Okay, so right now, you already know how to solve some parameters in designing foundations, like the lateral pressure, the slope stability of the soil, the retaining walls. Okay, so what is a foundation solution, or in other words, what is foundation? So foundation is the main supporting component of any building structure. So it is the lowest part of the building which is in contact with the soil and transfer all structural load to the soil safely. Okay, so without the foundation, you may not see skyscrapers in the buildings in the world. There are different types of foundations used in a construction depending upon the nature of the work. Okay, so in other words, the foundation is uh, one of the most important structural component of any building structure, of any structure. As we all know that any structure or all the structures are resting on the soil, okay, are resting on the soil, and without the foundation, we don't have we don't have a structure, or we don't have a building. Okay, so there are different classifications of foundations. So the foundation systems have shallow foundations and deep foundation. Okay, under the shallow foundations, we have isolated spread footings. We have wall footings, combined footings, cantilever or a strap footings, a raft or a mat foundations. And under the deep foundation, we have a pile foundations and pier or caisson foundation. Okay, so sige, pag-usapan natin what are the difference between the shallow and deep foundation. Okay, by the word itself, shallow or shallow foundations is when when the depth of foundation is less than the width of the foundation, or your depth is less than the width of the foundation. Then we all know that that is a shallow foundation. Okay, so generally, shallow foundation is placed no more than 6 feet depth from the lowest finished floor. So this is a typical depth of the foundation. However, basta ang depth is less than the width, that is a shallow foundation. Okay, a shallow foundation is generally used when, okay, number one is you don't there is a sufficient bearing capacity of soil available at shallow level, or at that depth. Okay, so sufficient yung bearing capacity mo. Okay, for example, your 4-story building, and you found out that approximately mga 3 meters below your ground is or 2 to 3 meters below your ground is capable to carry that much load. So hindi naman siya ganun kalaki yung foundations na gagawin. So, depends siya, nakadepende siya sa kung ano yung capacity ng soil mo at that depth, or at that shallow depth. Okay? And number 2 is the foundation material, or the strata do not result in undue settlement. Okay? Ibig sabihin yung that point or that shallow depth, hindi magre-result ng malaking settlement. Okay, so capable pa rin siya to resist that load. So number 1, sufficient yung bearing capacity. Number 2, hindi magre-result ng undue settlement. Okay, so the shallow foundation has a minimum depth of about 800 millimeter and a maximum depth not more than 4 meters below the ground. So these type of foundations are popular for low-rise to mid-rise building construction. Okay, so dadagdagan ko na lang mga mid-rise building construction. Okay, bakit sinabi na 4 meters below the ground? Okay, kasi kung ang mangyayari is more than 4 meters na yung ground level mo, or ground to foundation mo, your column, okay, your enforced concrete column, let's say, is have a great slenderness. Okay? So masyado na siyang slender. Okay, slender na yung column mo. And it's more susceptible in backling. So that is why shallow foundations are limit to 4 meters below the ground. Okay, so kapag mga more than 4 meters na yung required for that loadings, mga let's say, ito na yung kilonewtons na kailangan ng foundation mo, or ito yung total actual load and total moments na kailangan ng foundation natin. And you found out that the soil bearing capacity at that 4 meters below the ground is not capable or not economical to use since the bearing capacity is not acceptable or hindi siya ganun kaganda. Okay, so therefore what you need to do is maybe change ka na to use depth a deep foundation. Okay. So footings are more important, footings are the important structural element that transfer the load of column or a beam or a slab or attaining structure to the soil safely. Okay, so to transfer the above loads properly to the soil, footings must be designed to prevent excessive settlement, minimize the differential settlement, and provide adequate safety against overturning and sliding. So there are different types of shallow foundation in a building construction. Number one is the isolated spread footing. So it is one of the simplest and worldwide popular foundations. So an isolated footing is mostly used to support a single column. Okay, so it is used for a single column. So this type of foundation is suitable when columns are not closely spaced. So there are other subtype of isolated spread footing or isolated footing. Number one is the step footing. Number two is the simple spread footing, and number three is the slope footing. Okay, so ito yung simple and spread footing. This one is the simple spread footing. This one is the step footing, and this one is the slope footing. Okay, so the question is, the question is, why are designers uses this step and slope footing? Okay, so this one step and the step and the slope footing, this one. So why? Okay, so as you can see that in the step footing and slope footing, the thickness of the foundation near the column is much larger than the thickness of the foundation at the edge. Okay, meaning the thickness, this one, say T1, is less than the thickness at this near the column T2. Okay, so just like this one, your T1 is much lesser than your thickness T2 near the column. Why? Okay, question is why. So if you have taken up the reinforced concrete design, if you have taken up reinforced concrete design, and you study the design of foundations, okay, you all know that if your foundations, let's say a simple isolated foundation, okay, in the analysis of a one-way or a two-way shear in the foundation, okay, near the column is the most stress region. Okay, so ito yung critical part. So in two-way shear, that is D over 2 from the face of your column. This is D over 2, and this is also D over 2, or the effective depth or effective thickness of your foundation. That is for two-way. And for one-way shear, okay, and for one-way shear failure, that is D distance from the face of the column. So ito yung susceptible for shearing or for diagonal tension or diagonal crack. This one. This one is a D distance from the face of the column. So meaning that in order for the designer to pass the foundation, the dimension of the simple or isolated footing, ang ginagawa nila is pinapalaki nila yung depth ng footing near the column kasi doon yung mas mas critical. So that is why they introduce this step footing and slope footing. So yan yung parang parang industry technique. Okay? Yung industry solution. So kunwari restricted yung area mo, restricted yung area ng isolated footing mo. And hindi ka pwedeng maglaki ng size kasi masyado nang malaki ang size. Bumabagsak yung design mo sa one-way and two-way shear or one-way or punching shear. So ang gagawin mo, mag-i-introduce ka ngayon ng step footing and slope footing. So pinalaki mo yung thickness dun sa near the column and syempre, mas papasa na yung section mo. Okay? So that is why they introduce this step and slope footing. Okay, next one is the wall footings. Okay, for wall footing, it is a pad or a spread or a strip footings that are used to support structural or non-structural walls to transmit and distribute the loads to the soil. So all footing runs along the direction of the wall. So this wall foundation or wall footing, or sometimes they call as a strip footing, is uses for a wall or retaining structures. Okay, so yan yung mga wall foundations. Okay, so if you wonder how to lay CHB or the concrete hollow blocks, kung paano siya ginagawa sa building, so meron yung mga wall footing. Okay, magpo-provide kayo ng wall footing sa ilalim, then you have your CHB. Okay. Then magi-introduce kayo ng reinforcement dito. Then you have your dowel bars. Okay, mag-insert ka ng dowel bars. This is for your CHB. Okay? So typical niyan for a CHB, a typical vertical vertical reinforcement for vertical dowel bars is diameter 10 at 400. Okay, diameter 10 at 400. Okay, so this is typical for 150 mm, 100 mm CHB. Okay, so basically this wall footings by the word itself is a footing for walls or for a strip or yung tawag dito yung parang retaining structure siya, yung continuous siya along. Okay, so all footing that runs along the direction of the wall, okay, is what we call the wall footing. Okay, so yan yung wall footing. So for combined footing, it is provided when the column is closely spaced. So for example, you have closely spaced columns and nag-overlap, okay, nag-overlap yung foundation area na kailangan mo. So so that their footing overlaps with each other, and when the soil bearing capacity of the soil is lower, then this type of footings are used. So in such, when columns are closely spaced and if we provide separate isolated footings with overlap, in such cases, it is better to provide a combined footing than an isolated footing. Okay, so this happens when, let's say this one, you have a column, let's say dito you have a column, and the distance between them, let's say 4 meters. And you run your analysis. And you found out that the required dimension of the footing is, let's say this one. And you analyze this, your second column, you analyze it also as a isolated footing, and you found out that the required dimension is this one. Okay, maybe different colors. This one. Okay, so what can you say about the resulting dimensions of the two separated columns? Okay, So they overlap. Okay, nag-overlap sila. So therefore, it is much better to provide a combined footing than an isolated footing. So this is a solution when you have a closely spaced columns and the required what you call this, the required dimensions of the foundation is nag-overlap. Okay, nag-overlap sila. Okay. Next is a cantilever or a strap footings. So when two or more footing is connected with by a beam, it is known as a combined footing. So basically, if you have a column or if you have a footing that is connected by a beam, or sometimes they call this one as a footing tie beam. We call this one as a footing tie beam. Okay. So they call that foundation as a cantilever or a strap footing. Okay. So this is an important foundation. So when a square or rectangular footing is located near the property line, and if it concentrically located under the column, it would extend into the adjoining property, which may not be permissible. So for such situation, a trapezoidal combined footing may be an alternative, or maybe the use of this cantilever or strap footing. Okay, so this is an example of an actual design of foundation. So this one is my in my recent project. So ito yung foundation solution in my previous project. Okay, so what happened? Kailan to ginagamit yung cantilever or strap footing? So for example, you have a foundation or you have a column near the property line. So let's say you have a property line, this one. This red is your property line. And your column is located, so maximize yung area ng property. So your column, let's say, is located this one. And your other column is located to this one. Okay. So maximize yung dito sa left property. Okay. So you cannot create a foundation outside of your property line. So mag-aaway kayo nung kabilang lote. So ang mangyayari sa foundation mo, is dito lang. Okay? Hanggang dito lang yung foundation mo. Okay? So if we study this type of foundation when you have a column near the property line, so ang nangyari sa foundation na yan is nakaganito. Okay? Right? So yan yung this one is yung blue column. So nandun siya sa edge, di ba? Nandito siya sa edge. Then ito yung footing yung foundation natin. Okay. So this is a high eccentric footing. Okay. Bakit ko sinabing high eccentric footing? Since let's say you have your axial load over here. Okay, may axial load ka dyan. And you have a very large eccentricity since nandun ka sa edge. This one is your center line of your foundation. So you have a large eccentricity. So what do you think will happen to this foundation? Okay, so the possible cases that will happen to this foundation is at this point, we call this one as the heel. Okay, so overturn yan, aangat yan, di ba? So pwedeng mangyari, aangat siya. Umangat yung ating footing, just like this one. Okay, pwede siyang mag-overturn. Okay, so this is an example of, this is a failure state or limit state na yan ng ating foundation since our foundation cannot, the soil cannot resist tension. Okay, the soil cannot resist tension. So this is, it will result to settlement of your foundation and columns, and also a large crack has seen in your walls kung ganyan yung mangyayari. So the solution is to provide a connecting beam or a connecting or a footing tie beam, okay, on the other side of the foundation. So what will happen is you need to provide, this is the foundation solution, that you need to provide as a footing tie beam, and at the other side of the column or yung adjacent column. And this time, nadagdagan yung strength of your column at yung edge mo, yung may column na may moment mo. Okay? Since hindi niya na to mapapaangat. Okay, let's say kung may load ka dito, ito yung eccentricity, hindi niya na to mapapaangat because nakasama na, kinonect mo siya dun sa isang beam. So pag inangat mo yan, dapat aangat din to, di ba? So meron kang dalawang kokontra, yung concrete pad nito, and yung concrete pad nito, and also the column loads of this above load. Okay? So yan yung very kailangan nyo sa pag nagde-design kayo. So you need to check kung ano yung global performance of your structure. Okay? So this is a cantilever or a strap footing. Next is a raft or a mat foundation. Okay? A raft or a mat foundation, or sometimes they are interchangeable. Okay, so it is a continuous slab that covers the entire area of the building of a foundation and transfer its weight to the ground. Okay, so kaya siya tinawag na mat or a raft foundation is because basically ano siya marami kang column sa footing na yan. Okay. So what is the difference of rough foundation or mat foundation dun sa combined footing? Okay? So basically, a mat foundation is a combined footing. But a combined footing cannot be a mat foundation. Okay? So nagets niyo ba 'yan? A combined footing, a mat foundation is also an example of a combined footing. Okay, but a combined footing is not an example of a mat foundation. Okay, so why? Okay. Let's say you have a closely spaced, again, column, a closely spaced column. And the solution or yung na-solve mong dimension of your isolated footing, let's say this one din, yung isa, may distance ka pa ng konti. Then yung also this one, nag-overlap siya. For example, ito nag-combine sila. Okay? Then also this one, let's say ito pwede mo silang i-combine. Dito nag-overlap sila ganyan. Okay? Yan. So, there is a constructability issue in this site because meron tayong maliliit na space na hindi pa natin i-excavate like this one. Hindi natin siya excavate. So anong nasa isip nyo na itsura niyan sa taas? Okay. Ang makikita nyo is nag-excavate ka dito, then ito natural nasa NGL pa rin siya, then excavate ka ulit. So may maliit kang distance na natira. So parang may maliit ka na retaining wall na soil, tama? Then dito may maliit kang retaining wall na soil, pati rin dito. Okay? So hindi siya ganoon kadaling gawin. So pwedeng masira yung maliit na yan. Okay? Then the solution is, what if lahat sila ipagsama ko na sila sa isang foundation? So i-combine ko sila sa lahat ng foundation. So the solution is, let's say, what if this 6 this 6 column is rested under one single footing, or one slab na na footing, like this one area na footing. Okay, so they call this one as a rough or a mat foundation. Okay, so it covers the entire area of the building or some area of the building. So pwede kang meron kang different mat, so mat foundations. Okay, so yan yung mat foundation. Okay, then for the deep foundation, this is when your depth is greater than the width. Okay, the depth is greater than the width. So a foundation in which the depth of the foundation is more than the width of the foundation, it is known as the deep foundation. So there are two types of common known types of deep foundation in a building construction. Number one is the pile foundation. Okay, the pile foundation is a type of deep foundation, and it is made of concrete. Okay, sometimes they use timbers or steel. Okay, but this is not commonly used because yung timber and steel, when rested on the soil, ang mangyayari sa kanila mag-erode. So or magko-corrode. Sa steel magko-corrode yan. Then sa timber magra-rot yan. So since bawal sila expose sa natural soil or natural earth. So it is like a small diameter column that is driven into or cast into the ground. So pwede natin gawin, i-driven siya or pwede siyang i-cast in the ground. So driven, ito yung nakikita nyo na pinapalo. Okay? So hinahammer yung pile para mag drive into the soil. And there are also an pile foundation na kinakas na siya sa ground. So ibig sabihin maglalagay ng casting doon sa soil, then magpo-pour ng concrete, nandoon na siya nandoon na yung foundation na yan. So hindi siya driven. Okay? So in simple words, the pile foundation has depth more than a shallow foundation. So this foundation primarily used in bridge construction and sometimes used in mid-rise and high-rise building. So minsan mas maganda pa na gamitin yung pile foundation compared to the mat foundations. Okay. So kailangan pa nila mag-provide syempre ng mga cost analysis kung saan yung mas better na foundation solution. Okay? So this type of foundation is used when the soil below the foundation does not have a sufficient bearing capacity to carry the load of the building into the deep soil up to the hard strata. Okay? So the solution is to provide yung deep foundation or the pile foundation because let's say the soil bearing capacity in your in that floor in that specific depth is not sufficient to carry the total loads of the building. So the solution is to find a depth in the soil or maybe going near the hard strata. Okay? So dun ka makakahanap ng sufficient bearing capacity to carry the load of your building. Okay? So the major function of the pile foundation, just like the foundation, the other foundation function, is to transmit loads to the lower level of the ground by the combination of friction pile and end bearing pile at the pile point or the base. Okay, so just like the different type of foundations, their main function is to transmit the loads, okay, from the lower ground up to the base or up to the bottom of your foundation. Okay, so in this picture, this pile foundation example, okay, this is your piles. Yan, yung long dito. Okay, this is your piles. This one and this one. Okay, these are your piles. And yung kanilang yung parang kanilang platform is we call this one as the pile cap. Okay? And this is your column. So when your load, okay, nag-apply ka ng load dito, let's say that is R or P, let's say the P. Then ita-transmit yan dun sa pile cap, and then yung pile cap yung magtra-transmit dun sa mga piles. So yung P, let's say magkakaroon yan dito ng reaction, let's say R1, this one is R2, R3, R4, R5, R6. Okay, so summation force is vertical, your P is equals to the summation of the reactions of your pile or of your piles. Okay? So yan yung purpose ng piles. Okay? Then in the pile cap, meron yung insertion. So let's say ito yung pile cap mo. Okay? Ganito yung reinforcement yan sa loob. So this one is your pile cap and this one is your piles. Okay? It doesn't matter if you have driven pile or casted piles. Okay. So meron yung insertion dito, meron yung distance, specific distance. Then you have a high grade reinforcement. Okay. So hindi lang siya grade 60. They sometimes they use grade I don't recall, maybe grade 70 yata yun. Grade 70. Okay. So ito yung reinforcement of your piles. Okay. Then you have your pile cap just like your typical foundations. You have your pile cap. Okay. So yan yung reinforcement of your piles. Then kapag bilog yan, spiral yan. So meron ka ditong spiral reinforcements. Okay, just like then also this one. Okay? So yan yung reinforcement of pile. Okay? So there are two types of load bearing piles. Number one is yung end bearing piles and number two is yung friction piles. End bearing piles meaning that the only reaction, that the only reactive force to the actual load P is yung nandun sa end piles. Okay, ibig sabihin, ang assumption sa design is nandito sa may end bearing. Okay, so summation, so di ba, let's say your force P, should you have your R1 over here. Okay, may R1 ka dito. So ito yung end bearing. So you have your R1. Okay, just like this one. So ito yung area of, let's say this one is your B and H of your foundation of your piles. Then the stress is equals to PR1 over B times H, right? So this stress, you have a sigma, let's say sigma, and compare it to the end bearing capacity of the soil or the bearing capacity of the soil at this area, at this point, is in equilibrium or capable to resist this end bearing stresses. Okay, so yan yung assumption for the end bearing piles. Then for the friction piles, the assumption is you will consider the contribution of cohesion and frictions that your pile experience along its length. Okay, so meaning you have your piles. Okay, let's say this one is your piles, and you consider your tip. You consider this frictions or the cohesions of your piles along its length. Okay, so you consider this one. Okay, that is the friction piles. So basically, this load-bearing piles depends on the assumptions of the designer or the geotechnical engineer recommendation. So number one is to use the end-bearing piles, and number two, use the friction piles. Okay, now for number two, we have a pier or caisson foundation. Okay, so for this one, for friction piles, balik ko lang. So for friction piles, your material, yung pagko-construct nitong pile na to is different from end bearing piles, kasi yung friction piles kailangan yung skin friction, yung exterior of your piles should capable to resist that friction, kasi kailangan mo i-consider yung friction din sa assumption ng friction piles. So dapat mas maganda yung pagkakagawa dito sa may friction piles. Okay, so for number two, we have a pier or a caisson foundation. So a caisson is one type of watertight retaining structure used in construction of a concrete dam. So as a pier or of a bridge construction in the river or the repair of the ships. So caisson is prefabricated hollow box, okay, or a cylinder sunk into the water or ground to some desired depth and then filled with concrete, thus forming a foundation. So caisson foundation is majorly used for bridge construction and other structures that require foundation beneath rivers and other bodies of water. So this is because caisson can be transported by floating to the construction site and sunk in water to use as a pier or a foundation. Okay, so basically, the Quezon Foundation is also the pier of your bridges. Yan, yung mga pier ng bridges na yan. So if you wonder paano ba ginagawa yung mga foundation sa mga may water below. Okay. So ang ginagawa nila, meron silang pang watertight retaining structure, then in-open nila yung gagawa sila ng hollow box doon sa sa bodies of water. Then kung medyo natanggal na nila, magsisip out sila niyan, magpa-pump sila ng tubig doon sa may bodies of water. Then after nilang ma-reach yung certain amount of water na gusto nila, yung mga may tolerable limit sila, so magpo-pour na sila ng concrete. Siyempre, magkakas muna sila ng reinforcement doon. So, gagawa sila ng reinforcement doon sa And also, magpo-pour na sila ng concrete. Dapat, yung caisson or yung pier foundation is watertight. Kailangan yung exterior of that pier foundation is watertight kasi dapat hindi mag-penetrate yung water doon sa foundation mo kasi mangyayari kapag nag-penetrate yung water mo dun sa foundation mo, magko-corrode yung steel. Kapag nag-corrode yung steel, lumalaki yung volume niya. Okay. Ang problem po kasi sa steel, yung mga rebar na yan, yung mga reinforcement na yan, kapag na-corrode yan, lalaki yung diameter niya. So, for example, ang bakal mo 10 mm. Kapag na-corrode yan, okay, meron niyang mag-expand yung kanyang volume. So may magaganyan yan sa gilid. Tama? Magaganyan yan sa gilid. So minsan nung maabot yan ng mga according to doon sa nabasa ko, minsan nung maabot yan ng mga 15 to 16 mm. Parang almost 1.5 yung nilalaki. Minsan daw may 2. Okay, so lumalaki yan, nag-expand. So ang mangyayari sa sa concrete mo, so meron siyang inner tensile stress. So as you all know that concrete cannot hold tensile stresses. Hindi siya ganun kaganda sa tensile strength of the concrete. So mangyayari dun sa reinforced concrete mo. Okay, sa reinforced concrete mo is mag-expand, magka-cause ng cracking, di ba? Mag-cause ng cracking yan dito. Okay. So that is why we need to tighten up or watertight. Okay, kailangan natin mag-create ng water tightness dito sa caisson na to para hindi mag-penetrate yung water. Para hindi magkaroon yung steam. Okay? So they are similar to file foundations but are installed using a different method. Caisson foundation is used when the soil of adequate bearing strength is found below the surface of layer of weak material such as fill or peat. Okay, so that is the difference between the shallow and the deep foundations, and also their common subtypes, yung mga common types of shallow and deep foundations. So if you have questions, please write it down. So if you have concerns regarding these foundation solutions.